This is the continuations of the example previously in the nodal. Then you have to find the Vx and Vz. In the previous example, you already find the I1, which is 0.0789 M, I2, I3, and I4. By referring to these circuits, you need to find the Vy and Vz as mentioned in the circuit. So from the circuit, you can see that for the Vy, so Vy is the voltage across 3M source here. So Vy, the current source is parallel with the 4 ohm, as you can see in here. So it means that the Vy is equal to the minus V at 4 ohm with a opposite direction. As you can see that if we are considering the currents in the clockwise, so the currents will enter through the 4 ohm by using this direction, and then we assume that the currents is positive and negative. But the Vy is in a opposite direction, or we can use the KVL to confirm the equations polarity by using the KVL equation at this loop. For example, by using the blue loop, we start with the current source, which is plus V3M, and then plus with V4 ohms is equal to 0. And then the V3M is equal to minus V4 ohm. Okay. So from here, you can see that when you select this direction, it means that you have to do the Ohm's law, which is V4 ohm is equal to I that flow through the 4 ohm times with R 4 ohm, which is I for the 4 ohms. The directions is same as the directions of the I3, which is I3 minus with the I4 times with R4 ohm, and then I3 is 2.553 minus with 1.053 M times with 4, and then the answer will be 1.5 times with 4. So this one is equal to 6 volt. So substitute this into this equation, so it will become minus 6 volt. And then for the Vz, so Vz is equal to V at 4 ohm. Therefore, Vz is 6 volt. So this one will be 6 volt. Vy will be minus 6 volt. So determines the power delivered by all source. So from here, you have to find the equation for each of the elements. So okay, P is equal to IV. So it means that you have to find the voltage for each of the element. So I select, for example, here as a plus, minus, plus, plus. And then determines the equations of each element. Either it has a positive or negative IV. The equations for 5-volt voltage source will be P equal to IV and negative because the current is entering from the negative. So from here, IV 10 ohm. So I select the current is flowing through the resistor. So IV is 4 ohm. So here the currents will be I2. This one I1. For the 4 ohm, you have to know the currents that enter the 4 ohms resistor. So I choose this one as a positive IV. And then I 4 ohm and then V 4 ohm. So for the first, which is the P at 5 volt. So equal to minus I1 times with V. 5 volt. Then you can get the answer by multiply the I1, which is stated at the circuit, times with 5. And I think you should find the answer by yourself lah. So numbers 2, P at 10 ohm, which is I1 times with the V 10 volt, 10 ohm, so equal to I1 square R 10 ohm equal to 0.0789 square times with 10. For 8 ohm here. So I 8 ohm times with V. So I 8 ohm is equal to I1 minus I2 square times with R, which is 8. Okay. So I already convert by this one, I square R. For number 4, P 4 ohm is equal to I2 square times with 4 ohm, which is minus 0.4474 square, and then you have to times with 4. For the P, another 4 ohm here. Yeah, this one is a difference 4 ohm. I3 minus I4 square times with R4. 3 and minus with 1.053 square. Time with 4. You have to calculate the answer by yourself. And then this one is a bit different, which is you have to find the power for the voltage source, dependent voltage source, which is P2 Ix. So which is the current is entering your positive terminals of the Vz. So I choose that as a I force time with Vz. So I4 is 1.053 multiply with time or times with Vz, which is 6. And then finally, so number 7, so which is the current source here. So you can see that the current is entering your positive terminals of Vy. So P 3M positive I times with Vy. Okay, which is 3 times with minus 6. So that is the answer. Actually, in order to know your answer is correct or not, you add positive P must be equal to the negative P. So it means that this one is stand for delivering power. And then this one is for absorbing power, or you can add all the power P is equal to 0.